Hey, how we all doing? Happy Tuesday. Sorry I couldn't be there again. Tennis is crazy this time of year, but this should be the last class I miss. Should be the last class I miss for you. So I know we're running out of classes, but let's do it. Here we go. I'm sharing my screen. We are learning about arcs and chords, so we're going to continue. We did arcs last time. We're going to continue and do some chords here as well. And today there's a lot of theorems. So you got to bear with me, no proofs. We're going to have a lot of theorems and then do algebra based on those theorems. So on 10-3, hope that goes okay. There we go. Let's just jump into it. Good to hear from you. Hope you had a great weekend. All right. Here's your first theorem. 10.2 says, in the same circle or in congruent circles, okay? Two minor arcs are congruent if and only if their corresponding chords are congruent. You guys are getting used to doing these little videos. So again, feel free to pause it, write this down, and then we'll talk through it. But basically what this is saying is this goes both ways. So if you know two chords are congruent, like if we knew F, G, and H, G, the chords, the lines themselves, the segments were congruent, then we would know that the arcs F, G, and H, G are congruent as well, okay? And vice versa. If we know the arcs are congruent, then we know the chords are congruent. Now, I'm not going to do this proof for you, but here it is. It's actually a really cool little proof. You make two triangles, okay? And then you prove that these triangles are congruent by side angle side because these are radius. So those, you already got two sides. And then you know that the arcs are congruent. So you know these central angles have to be the same. God, I do that badly. But you know what I mean? And so then you get side angle side, and then you use CP, CTC to say ST and QR are congruent. Pretty cool, neat little proof based on that theorem. You're not going to have to do any proofs, but I like that one. So basically, it's really pretty easy to start here today. We can see that the arcs here are congruent, so that means the chords are congruent. So you just got to set them equal. That was a wild two. We are starting off hot, folks. That was wild. Okay. So we got 2x plus 1 equals 3x minus 7. Just solve. We get x on the right. We get 8 on the left. We get x equals 8. Then you can plug it back in. 24 minus 7, 14. Does that seem right? No, 16? Jeez, can't even think. This one is 17. Oh, yeah. 24 minus 7. Yeah, 17. Jeez. Can't think. Sorry about that. 17 there, 17 here. Boom, there it is. All right. That's the first theorem. Nothing crazy happening there. I don't even know what we're trying to find. Maybe we're just being told that there's arc bisectors here. So we might have arc bisectors. So FH is bisecting the arc JG, splits it into two even arcs. So that's an arc bisector. Arc bisector. There might be a theorem with that. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay, this one is first one, right? This one was pretty easy. This one is a little weirder, but it's useful, super useful. Okay, so what they're basically saying is this is the diameter AB, or you can think of it as CB, the radius. If it becomes perpendicular with any chord, okay, so we got a right angle here, you know it splits the chord into two pieces. So no, that means we know XZ and ZY are congruent. And it also means their arcs are congruent. So arc XB and arc BY are congruent, okay? It's a lot of info from one little thing, but we need it to be this perpendicular intersection. If it's not perpendicular, this is not true. All right. This is a pretty wild one, and we're going to use it in a couple different ways. So let's see. All right. So right off the bat, right, we knew the chord splits in two because we got our perpendicular. So these are both 6. PT is 6 and TR is 6. And then we know the big arc PQR is 98. And we want to find arc PQ. Well, PQ and QR are congruent because of that last theorem. Okay, so we know that they equal together. So all we got to do then is 98 divided by 2, which gives us 49. So PQ and QR are both 49 degrees. Again, sometimes be really careful. I know this was confusing the other day for some people. Sometimes we're going to be talking about degrees if we're talking about measures and arc measures. Sometimes we're going to be talking about lengths, like 6 down here is a length. So really try to keep your units straight and make sure you know if you're in degrees or in length. All right, there you go. There's the book's answer. Nothing super crazy there. Wow, we're kind of flying. I think we get a couple more trickier theorems, but we are kind of flying. Next thing. The perpendicular bisector of a chord is a diameter. So this is the opposite. This is the converse of the one we just did, okay? This is, these are converses. So basically, if you know, now you got to know two things now, okay? You need to know that the chord is being bisected so that X, well, we should name this so you can see it. Like if this was Z, so we know XZ and ZY are congruent. So we need to know that. Plus, we need to know it's perpendicular, okay? If we know those two things, then we know that AB is a diameter and CB is a radius, okay? So we're going to use this one maybe a little less often because this is something you'd use more in proofs, to like prove something's a diameter or something. And I don't even think we're going to do this. Here's a problem if you want to test yourselves, but trying to keep these videos have been around 20 minutes, which is a touch long, maybe? I don't know. If you're pausing them, how long does it take you to go through them? 30? Guess that's not too bad. Anyways, if you want a little challenge problem, how can you use this theorem to find the center of a circle? Right. Okay, now this gets interesting. This is where we're going to use it in. This is really interesting here. Okay. So this is actually, it's not going off of this theorem. This problem is going off of this one, right? Where we just have the perpendicular. We don't know it's a bisector yet. But we know this is perpendicular, and you can just see it's a radius, right? You can just see that it's a radius. As it goes from the center to the edge. All right. We want to find TV, this length here. All we have is this is a perpendicular angle. What'd you say? Stella? Yeah, Stella, that's right. Yeah, so that means TS, because we have our perpendicular here, perpendicular angle, TS and SV have to be congruent. Okay, so we know those are congruent. We don't know what they are. Shucks. What do we do now? A little bit stuck, aren't we? We're a little bit stuck. So what we can do, hold on, I'm just thinking here for a second. Wait. Okay. Yes. Okay. Got it. So I'm just re-clarifying in my head what to do. What we can do is we can make a line. We got to add some. Okay. What's that, Surfell? Surfell, nice. Dude, you got it. Surfell misses all of last class and just comes back firing. What a legend. Okay. So we make a line from R to T. Okay. What is that length, everybody? What is RT? Yeah, it's a radius, okay? It is a radius. So we know the radius looking at UR is 11. So this is 11 here. And then we want to find X. Seems like we have a triangle. Maybe we redraw this. Triangle. This is 11. This is 6. This is X. Maybe we could do trig on it. Wait, but what is this angle here? Is it 90? You better believe it. These are vertical angles. So that is 90. So we can just do Pythagorean theorem here. Pythagorean theorem. It's never going to leave us. Never going to leave us. X squared plus 6 squared equals 11 squared. I don't know if this is a triple. I can't. Oh, I don't remember it. X squared plus 36 equals 121. Subtract 36. What do we get? X squared is equal to 85? Does that seem right? Yeah. 85 does seem correct. Take square root. Can we get X is equal to square root of 85? Can we break that one down? I'm guessing not, but I am not sure. I think that's it. I think we can break that one down. 5 goes in there 17 times. That's pretty bad. That's probably it. 25 doesn't go in. I think that's your answer. So this is the tricky one that people have tricky. They don't know where to start. You're going to just have to remind yourself. You can create as many radii as you want. You just go center to the edge. We know this radius is 11. You can make a triangle down here. Okay. Now they did want TV and they wanted us to double this. They wanted the whole thing. So I guess X is not everything. So TV was 2 times square root 85. Okay, and that can be your answer. Hopefully I did that math right. If I didn't, hit me up in the comments, kids. Hit me up in the comments. All right. So there you go. That is everything we've always wanted. So that's the hard part of starting this and hey, I can draw a radius and I know what the radius is. All right. Geez, we're cruising. That's the tricky one. I think we got one more theorem, a couple more problems, and then I think we're done. Not too bad of a section here. Oh, and this one isn't even that bad. That was the tricky one was the last one. Okay, 10.5 says, in the same circle or in congruent circles, 2 chords are congruent if and only if they are equal distant from the center. So again, we talked about if and only if a couple times. Remember, that means it goes both ways. So this is saying 2 chords are congruent if they are the same distance from the center. So JH and FG are going to be equal if we know they're the same distance away. And if we know 2 chords are equal, we know they're the same distance away from the center. Okay? So it can work either way. It can work either way. All right. And I think this is always going to be perpendicular too. I don't know if there's a theorem on that, but that seems to be the problems we get is they always turn out to be perpendicular. All right. Here we go. Let's do these. I'm trying to think. Sorry, I'm like thinking of who I should shout out. Some of you guys were like, I need a shout out. I'm like, can't even remember who said that. I think I got Stella, but that's all I remember. Okay. So in circle A, WX and XY are both 22, and we want to find AB. So we know if these guys, WX and XY, are congruent, they're both 22, that their lengths, that they have to be the same distance away from the center if we do this little perpendicular line. Remember, perpendicular line is the quickest way from a point to a line, so maybe that's why it has to be perpendicular. Remember we did that? That was that super long problem all those years ago. Okay, so these have to be congruent. What's that, Gavin? So we set them equal. Yeah, you're totally right, dude. I can't even draw. Sorry about that. Let's try it again. All right, let's do green. 5x equals 3x plus 4. Oh my God, such a difficult problem. There is some stuff in the circles chapter that's like seems a little easy. But it's good knowledge. It's good knowledge. So we get 2x equals 4, x equals 2. Okay. And then they want us to plug that back in. AB, so AB is just 10. What is that shape? Sorry, I'm using a mouse I'm not used to. Yeah, that's messing me up a little bit. Okay, AB is 10. All right, cool. Now, let's try the next one. Did we get it? Yeah, 2 and 10. Nice. So then we can go the other way. Remember, it's vice versa. Vice versa. That's what if and only if means. Okay, circle H. We know PQ is 3x minus 4 and RS is 14. And then again, you see that they're the same distance from the center. So these also have to be congruent then. Okay, so again, you just set them equal. What color is this? Oh, purple. So we get 3x minus 4 equals 14. Do a little math. We get 3x equals 18. Like the book isn't even trying to give you fractions. Like, you know, jeez. X equals 6. We just wanted to find x. Boom. Finito. Not too bad, right? That wasn't too bad. Just a couple of theorems, couple of problems. The section isn't too bad. Just a quick reminder. When I get back, we'll do one more section together. And then we're going to have a review day. Then we're going to have a quiz. And then we're going to learn one more thing. And then we're going to review for the final. Okay? So we're getting there. We are getting there. When I come back, we're going to just do one learn, one review, one quiz, one learn, 2 reviews. So when I come back, we're down to 6 classes. Holy moly. And then we have that stupid unified day. I'm not counting that. It's been a pleasure. It's been an honor. Hope you learned something. Signing off.